Hello everyone, I am Abhishek and this is your channel Glory of Code. In this video, we will be creating our AI model. Basically, it's gonna be a deep learning model. Why deep learning? We will talk about this later in the video. Without wasting our time, let's go to our workspace as we are already late. So, let me give a brief introduction about the project. DoctorG is a AI powered model which takes symptoms in natural language and tells you the disease which are most probable according to that symptom. So let's see the dataset first. This is the code which identifies the disease uniquely, and the name column, which is the disease names column, and the symptoms column identifies the disease's symptom which points to that disease, and the weight column is that which states the weight of a symptom in a particular disease. It's helpful when symptoms are clashing between the multiple disease. In that condition, the disease holding high value of all the weights will be considered. It's fixed here, but let me share an important factor that will play a crucial role in the future upgrades of DoctorG. This insight will be valuable when scaling DoctorG or enhancing it to the diagnose like a real doctor. The weight assigned to each disease will not remain constant over the time. It will change dynamically based on various factors such as time, region, seasons, age, etc. For example, people living in Delhi having different immunity and susceptibility in compared to those who are living in Bangalore. Okay, we will discuss more interesting aspects in the future scope section. But for now, let's get back to the topic. Now, see, this is the description section. It's helpful to tell the user about the disease. It looks like it needs a lot of cleaning. So now let's talk about the roadmap which we will be using. We will perform these 4 steps in a sequence. Initially, we will pre-process the data. There are lots of steps in pre-processing the data, and then we will create our model. We will do lots of things like label encoding. We will create neural network. We will choose our activation function, optimizers, and loss function, etc. And at last, we will create our AI agent to guide the user from the description. So let's get to our Google Colab. Let me load the data first. Import pandas as pd. We will create our data frame pd dot read csv. This is the name of our dataset, DoctorG underscore data. Okay, so let me show you the rows. How many rows are in our dataset? So there are around 8085, around 8000 data. We have around 8000 of data. Okay, so let me check. Yes, it's been working fine. First, our task is that we have to remove our code column. Actually, it's not much necessary, so we will remove the code column. Okay, everything is in small code. See, this column has been removed. Now, what's the second step? We have to change everything in lowercase. So, what we will do, we will simply choose our column. The first one is name, and the second one is symptom. And we want this be in lowercase. Yes, it's working. Yes, it's been done. We have removed the code column. We have created the disease name in the lowercase. Symptom, we have created the symptoms in lowercase. Now it requires symptom tokenization. Now we want to tokenize our symptom. So first we have to import Spacey. We'll use Spacey here. Then we will load Spacey dot load. Basically it takes a wordnet web _sm. Here we wanted to tokenize the symptom and we had to remove the stop words. Okay, so we will do is that what we will do, we'll create a function process symptom which will take text. It will talk, sorry, doc equals to NLP str text dot lower, and then we create tokens equals to token dot next, token dot text for token in text if not token dot is top and token dot is alpha, then return tokens. And then what we'll do, we will in symptoms we will apply the process symptom. Okay, let's see how it works. It will take a little bit of time. Let's see. So what's the error here? Instead of text we have to add doc. Let's see now. So yeah, it's done. It took approx 1 minute. Okay, so what we have done, we have removed the code column, we have lowercase the disease name, we have lowercase the symptoms, we have tokenized the symptom, we have removed the stop word. It's time to pre-process description. We have to lowercase description, and then we have to remove symbols. So now for processing description, what we can do, we will create a function def cleared description, which take description doc equals to NLP str description dot lower. We will print doc here. So first let me call this function df description equals to description. So actually it crashed. I think the reason was I printed doc. So instead of printing, let's do something pre-processing first. Port rejects, then we will cleared description equals to rejects dot sub r. Quickly let me paste the regex which I have written already. Instead of description there would be desk, and this will remove an extra space. This regex will remove any unnecessary symbol, and this will remove extra white space. And now we have cleaned our dataset. Now we have written the function to clean the description, and let's run this. Okay, so I started the runtime initially. So actually the error is the df is not defined. Okay, it crashed. I killed the environment and I reinitialized a new environment, so I have to run all this. Fingers crossed. It took a long time, so finally it's been done, and it took a long time, approx 12 minutes. So the description has been cleaned. So let's see what we have done till now. We have removed the code column, we have lowercase the disease name, we have lowercase the symptoms, we have lowercase the symptoms, we have tokenized the symptom, we have removed the stop words from the symptom, we have lowercase the description, we have removed the symbols from the description, and we have removed the extra white space from the description. And now it's time to weight scaling. So why weight scaling is necessary? So here we can see that data is distributed between 0 to 100, which is a huge gap. So scaling a data set ensures that all features contribute equally to the model, which improves the accuracy and efficiency. Basically it enhances the performance of gradient based algorithm, which we'll be going to use like neural network, by preventing the large magnitude features from dominating, which is really an impactful factor in learning process. Due to this, it's leading to the faster convergence, and additionally it improves interpretability in regression models, and it enhances the effectiveness of regularization technique like ridge regularization and lasso regularization. basically we also call them L1 and L2 regularization. Overall, its result is more balanced, stable and efficient for machine learning models and even for the deep learning models. So here we will do weight scaling. So for that we will import min-max scaler sklearn dot pre-processing import min-max scaler. Yes. Now let's print. Okay, we have scaled our features also. Now at last I think we need to do embeddings. Okay, we have to create embeddings. So why this embedding is required? Embedding symptoms in DoctorG is essential for accurately processing user input, which improves the disease prediction and handle the variation of symptoms descriptions. Like since suppose a user can provide same symptoms in a different way. Like he could say I am having stomachache, or also he could say that I am having abdominal pain. Both things are approximately similar. Okay, so embeddings convert these textual inputs into numerical vectors, which captures their semantic similarity. So this ensures that even if symptoms are phrased differently or contain minor spelling errors, the model can still recognize them, match them correctly. Additionally, embeddings allow for efficient similarity matching, enabling the system to compare symptoms based on meaning rather than exact text message. This improves multi-symptom processing, as symptoms related to the disease can be grouped together in a vector space, allowing that model to rank that disease based on the weight symptoms, actually based on the weight symptoms relevancy. Moreover, embeddings are crucial for feeding structured numerical data as the x value. When we will create our neural network, we will feed that x values to our neural network. As deep learning models require numerical inputs rather than the raw text, so we will also need embeddings. By transforming symptoms into dense vector, the neural network can efficiently learn patterns. Basically, neural network does not takes raw text, it takes the vectors. So providing vector can lead to great pattern understanding. So what we have to do, we have to import sentence transformer from import sentence transformer. Okay, we will name this embeddings. Let's run this. It will also take little bit of time. Okay, till then we have completed this process. We have done the pre-processing, removed the code column, we have done with symptoms pre-processing and similar for the description, and we have done weight scaling, and also we have created the embeddings of the symptoms. And now in the next video we will create the model. So I will explain this in the next video, and in that video we will create our neural network model. So till then, let me show you the data first. That was our initial data. And now this is our pre-processed data. Okay, it's looking great. This is the embedding, and now this text is also being processed and it's looking fine. Okay, till then watch this video.